Bash scope actually is one of the transaction modes that we have defined, and from the complexity that we can omit today is that you have to know that the bash scope transactions is they are transactions where we see mm, two behaviors. Transactions are behaving through. Let me just go to the appropriate slide. It got stuck. Great, great. So okay, regarding those transaction modes, the bash scoped one is the complex in between all. We have four modes. The bash scope via which we define the multi-active result set based transactions, where we see more than one command acting to bring different results than the others. The mass transactions, simply said, mass transactions. And at the same time, we saw the non-mass transactions, and still they are bash scope transactions. The concern here is that we are seeing more than one, let's say, command in action, or we are seeing more than one commitment request to happen. Commitment in the sense of either to commit or to roll back a transaction. So briefly like that. This is the definition of what is the bash scope transaction. What is the bash scope transaction? So it's a way via which we see transactions behaving, definitely. Whether we are talking about the mass-based transactions. Mass-based transactions means here a shortcut for multi-active result set-based transactions, where we see a single transaction having more than one outcome. And this more than one outcome is not a query to execute. It is a command, basically. And we saw the example of the .NET we passed through now. And the non-mass transactions, which are actually queries, a list of queries where we can actually define technologies enhancing the time control of the transactions. We saw the example, and we talked about the save points. Save points means we are going to define time frames within the life cycle of the one transaction, the unique transaction, the same transaction. We define time frames, means time points that we can use in future time. Nominated technically here, save points. So conclusion of this bash scope transaction, I hope it's very clear for you, bash scope transactions. So the example, briefly and very quickly, the example of the bash scope transaction, the first one is the non-mass, means the non-multi-active result set based transaction, which we see mainly when we say the non-mass means we are going to see a list of queries, and we might see save points, means time frame points from within the body of the same transaction. The beginning of this transaction here it is, and the end of this same transaction, here it is, here we are saying comment, and see if this is the end of the transaction. So what is this? So we are making a commitment from within the body of the transaction. Still we are talking about all of this here, and still going here until here. All of it is the body of this transaction. The body of this transaction. So all of those, they are queries. Here is, it's a query also, but it is a save point. It is time definition point. Still, and here we are going again. We are making a commitment from within the body of this transaction. Here, this commitment is the rollback, and still we are continuing the transaction content up to here. All of those, they are queries only. Here, this commitment that comes in between, that comes in the body of the transaction, it is to roll back the transaction in question. Which transaction? The transaction already we are in, the tran. It's the same transaction. We are going to roll it back This transaction does not have a name here. It means actually we are starting a transaction without a name, without a user-defined name. So it is a transaction. That's it. The system will recognize that it is a transaction, and we execute it like that. This rollback will come back from whether the body of the transaction from here, the transaction here, defined here, we are in, up to the save point named save point one. Where is it? Here it is, save point one. It is saved already in the body of the transaction with the name save point one. Save point one is a user defined name. It's a name via which is user defined. We can say SV save or SP save point. Yes, we can change this name here. To be SP, yes, we can see SP1, save point one. Yes, we can do it like that. Yeah, why? Because it's user defined, no? As if we are given the name of a variable, new variable name, int A, int B, C++, for example. What is the A and B? They are variable names, user defined. The same way here, the save point here, it's user defined. But once we define this way, later on, when we use it, we have to use the same spelling, the same nomination, the same terminology. We have to refer to that variable, to that specific variable, no? So we have to use the same name. There is no secret. Any questions in plural in this transaction, please? Okay, I have a question. Okay, I have a question to you. What are those two lines? What do they do? What is the role of those two lines here? What is the role of those two, let's say, queries here, or those two lines, or those two commands here? What is their role? Can you just
Is defined.
tell me, yes.
Is define the name.
Define the name. Not exactly. It is talking about the save point. Yes, exactly. It is talking about the save point, the name of the save point, which is save point one. Okay, but what is the role? What do they do? Why we need them here? You are seeing what I'm highlighting, isn't it? You are seeing the part I'm highlighting.
Yes.
Yeah, exactly.
Yes.
So what are they doing here? When I tell you, for example, the one before, select star from T1. What is this? We are selecting everything. It's a SQL query. This is a SQL query. Select star everything from this T1. What is this T1? If I come back earlier, the T1 is a table. We already created it. The T1 is a table that has two columns, two fields, ID and title. Okay, select everything from the T1. Hey, okay, what are those two things here?
To back.
To back, no, the to back خلاص هذه to back, roll back. This is the role of this query will do the rollback. This query here, this command here does not interfere with those commands here. Simply here, just concentrate here. I need you to concentrate, please. This is the number 100 times I tell you about that. This is a command in SQL. This is the command that the SQL Server understands. Everything that comes up after two hyphens, everything that comes after two hyphens in SQL Server, and the query editor, query builder, will be seen as a command. This is a textual representation. This is just for us readers to understand or to clarify the content, no more or less. So the server, which is the SQL Server, will not interpret this thing. Will not neither interpret nor compile. So they will not be able to be. They will not be seen by the server. They are commands. Command. Is it clear?
Yes, Mister.
Great. Now we pass to this thing. What is this thing now?
Command.
What? It's the same thing. It's a command. It's just It's just a clarification, the same way here. It's a one-line command. When I highlight like this, for example, here, now see, I'm going to highlight those two. What are those two?
It is command, not to execute.
The first one is a command. The first line and the second line.
The fourth
Here,
line, don't view.
this one, yes, exactly. It is a command not to be seen by the server. True. And it is, remember, the two hyphens, they are a single line command. They are not a multi-line command. Multi-line command, we may use the star. We may replace them with /star. So all what it comes after is a command. But this is a one-line command, the two hyphens. If I highlight like this, now I'm highlighting a line with a command and then a line with a query. This is a query here. We continue. Be careful. So it is long transaction, yes, but it has so many commands. This is a mass transaction, or this is a non-mass transaction that has a rollback in the body of its, let's say, a process. The transaction in the body, we have a commitment, a rollback. Is it a mass transaction, multi-active result set based transaction, or a non-mass transaction? Is this or that? Clearly don't. Actually, be wait, please be with me. So since we are talking about the commitment in the body of the transaction, we cannot talk about the mass. It is not a mass. It is not a multi-active result set. It is not. Save points not to be utilized. Save points, they cannot be utilized in mass transactions. Cannot save points. Because mass transactions either to be executed once or not. Because the outcome from within the body of the transaction is related to the transaction, whether it is based on 2 commands or 3 or n commands. The same transaction means either you accept it, you admit it, or you don't admit it. So here we are seeing a save point. Then this is not a mass transaction. And clearly the title is saying non-mass. Pass to the second example here. Here we are going to see a different interpretation. We are starting a transaction. We are starting, let me come to the next slide. Here we are starting a transaction. Here it is. Given it the name run, here is user defined. This is a .NET solution. .NET means it's built in C# or VB. Here, since we are talking about semicolons, so they are all C# as per our book. So we are defining a variable, which is a SQL transaction, and to this variable we are linking 2 commands, the same variable, the same transaction, we are linking 2 commands, the command 2 and the command 1. What are they, those 2 commands? The command 2, here it is, it's a simple update query, command 2. Command 1, it's a list of queries. So 2 activities to do. Here we are going to display command 1, select, and in the command 2 we are going to make updates. So it's one direction process. Updates only. Both of them, they are 2 complete and different standalone commands. Then both of them here, I insist, they are both command 1, command 2, they are linked to the same transaction tran here, given the name tran. Here it is. Great. The body of the transaction, which is started here, here, the body, it has this process, the try block until here. This is the block. But this block here has to have, the try block which starts here, has to have, and finishes here, has to have a catch block. What is it? The catch block, actually, it is a block to be executed. This catch block, what it is, let me. Yes, the catch block, here it is. It is a block to be executed once what? Once the try block has failed. If the try block fails with an error, then the catch block only will be executed. So we are doing an exception handling inside this transaction. The same transaction run, the same run transaction. We are handling errors, let's say lifetime or real-time or runtime errors. If they happen, then if any happens, the catch block will be executed. So this catch block I will not speak about. Why? Because it is the exception handling. Here it is a simple message to display. The message is from this variable EX. What is this variable EX? It's the exception read here as a parameter. Good. The system will launch it. The system will launch it. Whatever the error will be detected, the system will write it. It would be displayed on screen here. What does this transaction do? Starts here, we said. It is going to populate. It is going to populate. Let's say an outcome, whatever. So as we said, the command number one, it is simple list of queries. The command number one, where it is. Yes, here it is. It's a simple. It's a list of queries to select, to display. select. So they are all to display only. They are all related to what? Is command one. But those selects here, they are to be read and used to fill up the entity or the entity T1. So the entity T1 is an entity that already we created earlier. It's a table. Great. And also the CMD, the command 2 will be actually utilized to update what was intended to be updated. Here it is, updated T1. It's another query. So query 1, query 2. We come to the end. We'll find the execution of both query 1 and query 2. Sorry, command 1 and command 2 will be executed. And once terminated, the transaction would be admitted here. Here we are talking about commit. This is the commitment. We may say rollback, but here in this regard, we are making a commit. In this example, the commit is there. So we are admitting. We are making the system save all the happened events. If we want to create a save point, actually a time frame point here related to this transaction, which command is going to be cancelled, or let's say, or which command is going to be admitted from within the body. It is hard. Why? Because the transaction is one transaction. The name is one run, and how to commit one of the commands separately, or how to roll back one of the commands separately. Also, it's hard. It's not feasible to commit or roll back those two commands each separately. No, we are admitting the transaction because the transaction has a body, and from within the body we are having two different commands in this example. We might have more than two. How to control each of the commands inside the same body of the transaction separately? It is not something feasible. It is not something realistic. So thus the transaction to be admitted or the transaction to be rolled back. Because here you may say, we just generate save point and we'll come back to that point. No, it is not like that. The body of the transaction here, from when it started, it is using the command 1 and command 2 in different points, where their definition is before the generation of the transaction itself. See, before, this is where the transaction has been generated. Here we created the transaction, but before of it, here the command 2 comes here, and also before of it, command 1 comes here. So both of the commands, they are defined before the start of the transaction. Before the start of the transaction, here it is. I hope it's clear. Okay, isolation levels, they are mainly, we defined only 5, but they are not limited to that. All of them, they are to avoid execution issues, and those execution issues, they are runtime issues, like the dirty red, non-repeatable red, the function red, and so on. All of those cases we defined, and we saw in the lab. They are issues that might happen within the runtime of the project in question. So to tackle each of them, we have to go beyond the isolation level to block such issues. We clearly manipulated the serializable mode, and we saw that it blocks the serializable, let's say, isolation level. It blocks all the usages on the entities that they are defined in the body of the transaction until the transaction has been finished. We given the 10 seconds time frame, if you remember very well in the lab, and the transaction would block all the updates or the inserts or the readers of the contents of the entities that they are in the serializable transaction. So regardless of the particular cases, isolation levels, they do solve the issues on top of the flow that happen, those issues that they have to happen, to be happening during the runtime of the project, or during runtime. A flow issue happens in runtime, not anytime, not in development mode. And you define what is the dirty red, the non repeatable red, and the phantom red. We defined all of them. Here they are. Simply talking, dirty red, actually, it is to falsify, or let's say the system will make a mistake. It is not by intention, no, but an error happens, and the error is to a commitment, or let's say a display, or let's say a data from session 2 would be actually utilized in session number 1. Dirty red. Yes, here it is. So this is due, as per an example, due to the rollback commitment. And this issue might happen. This issue might happen in certain circumstances, and the circumstances, usually we talk about the number of the requests per time, and the quantity of the data requested per time, also the same time. So do not expect any system will fail immediately from the beginning. No. The usage of the system might cause those issues. The issues to happen here in live flow, they might happen due to the usage, not any time. Due to the usage means the system is very fine. It will not happen with those issues to a system unless the circumstances happen. And the circumstances, they are the number of number of requests, number of users per time. The non-repeatable red is another issue that happens during the runtime only. And here we see that a transaction would retrieve data but does not see the updated data. Okay, you are going to see the latest marks I given you in the exams. You just click the button, but you do not see the latest mark. You are seeing an old mark. Why? You try again and again. It's the same. You are seeing only the old mark. Why? Because the system has fallen to a non-repeatable red issue. The system you are using, for example, the DUA, we can give the example because there are thousands and thousands of users per the same time of this DUA. So you are seeing old marks. You are not seeing the updated one. So the system has fallen into a non-repeatable red issue. The updates was not being displayed to you. To you, it means you as a user, whatever. What does it mean issues in live flow? Actually, can you just clarify to me before I continue, before I do anything? Can you? What does it mean issues in live flow? Issues in live flow might happen. Are you with me?
Yes.
Okay. I believe it's clear, but let me the last and the third example where transactions might fall into errors, or let's say might demonstrate or might show issues when running. The phantom red is a scenario which, like the example actually of the non-repeatable red, we are just retrieving data but does not show. Retrieving data does not show here due to the usage of the, let's say, the entity or the store, the data source by another session. You are retrieving but it does not show. You have to do the thing more than one time in order to see the results or see the final content. Quantum red. So circumstances here are as per an example only. As per an example, user number one is trying to retrieve data, but user number two is already utilizing the data. So you'll not see the content unless the user two has finished. Then after you have to refresh to see or recall again in order to see the data, the results or whatever. Phantom red, phantom red. Yes, the application of those isolation levels might solve the issues that you were describing, the phantom red, the non-repeatable red, and the let's say uh, whatever the let's say the runtime issues faced by whatever, because actually they are not to be seen by or notified by the not noticed by the end users. The users will see only the result, whether it is running or not, blocked or not. The explanation of why the serializable isolation level do block all the users of the entities that they are defined within the body of the transaction defined as serializable is that the serializable generates a deadlock on the entities defined in the same transaction, defined as isolated serializable transaction. The deadlock, it's a mono mode to use entities. It's a one unique path via which entities are being utilized. Transaction set as serializable. So all the entities inside will be only utilized by this given transaction until the transaction is finished. So the deadlock is happening. So here in this example, we are making an insert into accounting numbers. table, any trial to use the same count in numbers table or entity, when this transaction is being utilized, will fail, will be kept in a waiting queue. It will be kept in a waiting queue until this serializable based transaction is finished. At that time, the other transactions will be able to use the count in numbers entity. The deadlock, what we defined here is the deadlock. The deadlock is happening on the entities, all of them defined in this transaction. In this example, we are talking about count in numbers. Yeah, we set the transaction, actually syntax via which we set the transaction isolation level, serializable in this example, and then after we are going to define the body of the transaction. Here actually the wait for, it's a query via which we use to gain time, to specify time. We saw that in the lab, actually we saw this in the lab, we clearly utilize it. And this wait for here, it is to gain time only to see, because actually we, as a humans, the time to execute one or two queries, it's very short, and we cannot notice, we as humans, the time, because it's very short. It's a matter of click, immediately would happen. So to see the effect, we gain time before finalizing the transaction, and we see the impact on the others. So the deadlock here, if we count how long this deadlock will be remained on, for example, the entity test here, it will be the time of executing this query and this query, and plus this wait delay or this delay time, the wait for this time, this waiting time. That is a deadlock time frame on top of this test entity. Any questions here, please?
No, Mister.
Remember that the
No,
context
Doctor,
of
thank
the
you.
yeah, great. Remember that the context of the isolation levels, it is to solve issues happening on the transactions, and we said live flow issues. Do not expect to find it in a local environment, you at home or small company or something like that. No, it is basically on a very large and problematic environment, like the web. The web is, yes, a very rich library, let's say, and resources deliverer, but at the same time, it is complex enough to cause systems and services fail. Examples, those issues we defined earlier. Here, the issues that they are to be seen by databases or data stores in live time. They are questions to be seen in the web environment mainly, not only, because the number of requests to cause the system fail, it is not one or two or three or thousand or 2,000 or even 10,000s. No, it is not at that time. So it has to be really huge enough to cause the system fall into an issue like the whatever, the phantom red or the not repeatable or whatever, the web environment. Because if I ask you the following question, EduWave, defined by University of Lisbon as an educational portal or ERP system, how many people, the number I need, can utilize this system in the world? The answer is everybody. Everybody that has access to the internet can use the EduWave, because everybody everywhere, since they do have the URL of the EduWave, they can open the EduWave anytime, anywhere. So the number is huge enough to make you feel fear. Will the system run or not? Yes, this here you'll understand that the isolation has to be set, because feeling that the system will face an issue to deliver a resource to everybody. Yes, this is the framework where the isolation has to come into an action. Finally and lastly, the distributed transactions. It's a scenario via which we see queries requesting resources from different locations, let's say different entities. We are going to utilize more than one resource from different locations. They might be geolocations also, to terminate one transaction. Here we are talking about a distributed transaction. Instead of just typing run or transaction, we are adding the word distributed. Why? Because the content inside, it's a variety of resources. Distributed transactions. If you hear your name, please just say yes. I'm gonna just stop the recording.